Hello, everybody. This is Monica Paolini, and you are on our latest Sparring Partners. And it's on the Future Network is open and autonomous, and it's with Brandon Larson from Mavenir. Welcome you all. It's a pleasure to be here as always, and this is going to be a conversation that it's part of a sort of broader project. It's a report that I'm writing on AI and Gen AI driven automation. And we already had a Sparring Partners with Fujitsu, and we will have more. And the reason for this is to really spend some time thinking, talking, and exploring how AI and Gen AI are going to play a role in automation, and how and why automation is becoming more and more important and in the development, to support the development of our networks. And in this framework, what we're going to talk about today is openness, the relationship between openness and automation. And the argument that we're going to try to make is the two are not completely destroyed, but there is a reason why they all become important at the same time. Now, before we get to have Brandon in the fold here, I just wanted to have a couple of housekeeping items. As many of you might be already familiar, in Sparring Partners, it's a conversation. It's not a presentation on our end, so we look forward to your participation. It's an unscripted conversation, so feel free to participate, ask your questions as we go along. We do not have a real Q&A at the end. We get the questions as we go along. So whenever you have a questions, ask it, and we'll try to answer it. Maybe not immediately, but as soon as possible, as it fits into the flow of the conversation. And this is to allow you to ask more questions. You can also chat with each other if you want to. Keep in mind that what you type in is going to be visible to other users as well. So be polite, considerate, and respect other people's opinions. Said that, I would like to get started. So again, ask your questions as we go along, either through the chat, the chat or the Q&A. Both will work for us. If we cannot get to your questions, we will get back to you afterwards. But usually we do our best to get to answer to your questions right away. With that, I would like to introduce Brandon. Our guest today is Brandon Larson. He is the SVP and GM of Cloud AI and IMS at Mavenir. And so I would like to ask Brandon to tell us what he does. I mean, this is like an impressive portfolio of things to do, Cloud AI and IMS. That's just, it just seems like so much like 3 jobs at least. So Brandon, why don't you clear it up for us? How can you do all of this and probably more?
Yeah, thanks for having me, Monica, and appreciate everybody who's joining today. So good morning, good afternoon, good evening for everybody around the world. As Monica mentioned, I have a couple different roles at Mavenir. On one side, it is to run our cloud automation and AI solutions, and that's a lot about what we'll be talking here today. And then I also manage kind of products in what I call the telco proper, right? So our IMS, which covers voice and messaging solutions. So I have a kind of a blend of skill sets in that. And just talk a little bit about what we're doing at Mavenir today is in terms of the autonomous and open aspects, which we'll talk about today, is that we're working with partners across the ecosystems, companies like Red Hat, Microsoft, AWS, Google. And what we're working with these companies to do is leverage state-of-the-art technologies in cloud and AI and automation. And we're bringing them into telco to solve problems specifically for telco. And out of that, we're developing more autonomous networks for our telco customer base. So in a nutshell, Monica, that's what we're doing.
That's a lot of work, and I guess a lot of people think about Mavenir Open RAN, but what you do is actually so much broader than that.
Absolutely.
So it's a good opportunity today to talk about all of this as well. Okay, so let's get started to talk about automation today. As I said, this is one of your hats. Now, automation, it was like, well, obviously we know what you automate, right? But it's actually not. I mean, like with anything, really, we should really start defining our terms. What do we mean by autonomous networks, automation, autonomous networks? Let's get started.
No, that's great. So first I'll start with the term autonomous networks, and then I'm kind of explain the difference between automation and AI. Because as you said, a lot of people are conflating these in the industry or when I talk, and they really are complementary, but they do solve different problems and there's different solutions to them. So when you look at an autonomous network, I think of two things. One is the ability of the network to operate with less human intervention, typical automation type of value prop. But the other is self-governing. Right. So if you think about self-governing, the network actually has the ability to think for itself. So it's going to learn deeply about the events happening in the network, to traffic patterns, what settings are controlling things in the network. And after it understands that network deeply, it can then understand what actions to take, given a set of objectives or based on current conditions. That's where AI comes in. So when I look at automation, I think of doing an operational task that we otherwise do today. So you think about installing software, upgrading software, updating a configuration, scaling out, scaling in, terminate, right? Those are all operations that are being done today. And what the automation framework does, it does what I call allows the human to set a declarative objective. So in an automation framework today, a human operator said, I'm going to tell you what the state of the network is. And I'm going to give that, and I'm going to load that in the automation framework. And then the automation framework is going to take the network and it's going to get it to that desired state. But the operator doesn't have to tell step by step what it wants the automation framework to do, hence declarative. Important point, human is controlling the end state of the network. AI is a bit different. With AI, the AI is learning about the network by ingesting all this network data, and it's learning how the network works. And then it's actually applying that knowledge to problem solving and decision making. So it's doing things like, if I understand the network, I can understand the causation of why something's happening. So I think a causation is like if a lot of people are having heart attacks and you want to find out why are they having heart attacks, is it because they're smoking? It's the weight, family history. These are what they call attributes in a machine learning. And what we talk about in machine learning, it's called feature importance. Which things are impacting that? Sometimes it's not a linear correlation either. So these causation models are able to give operators deeper insight, not on what's happening, but why it's happening. That's important. We can also use machine learning to forecast events. So once it understands network behavior, it can see things coming, and that allows you to get out ahead of the problem. So stop it before it's happening. And then with reinforcement learning, recommendation is becoming a big thing. What do we want the network to do? And then what actions that needs to be taken in the network to achieve that objective? Well, machine learning will just figure that out. Hey, if I want to increase spectral efficiency, improve mobility, improve coverage, give the machine learning the objective, and it'll figure out all the different knobs to turn, and it'll optimize the network. And it'll be done in a way that a human couldn't even comprehend all that different data, all those different knobs, all the different consequences that will happen out of making that. But machine learning will figure it out. So that's kind of a long-winded explanation, but I definitely say, automation is the humans know what the end result is going to be. They set the objective. Automation just gets you there. AI/ML figures stuff out. And that's the big difference.
Absolutely. And I think that it's important to point it out because right now everybody talks about AI, Gen AI, and automation, but there is a lot of kind of confusion because everything is kind of conflated in some sort of odd ways. Now, an implication of what you said is that for the first steps, the first automation tasks, which are already implemented, you don't really need AI or Gen
True.
AI or anything. So maybe we can sort of stick them apart and then we put them together again. So where is that we do not need them?
Okay, so yeah, and I think now we're talking about what is the solution we deploy for automation, and then what's the solution we deploy for AI ML, and that's very important. Let me break it down. So when we talk about automating networks, right, we're really talking about what I call the arms and legs. You know, how do we get things done in the network? And really, it all starts with moving to Kubernetes cloud. So we've seen a big shift in the industry moving from OpenStack to Kubernetes, and I always tell people that right there is a key to getting a more sophisticated orchestration engine, which is going to drive automation in the network. So we start with that Kubernetes cloud, have a much more sophisticated orchestration layer. On top of that, we bring what we call GitOps. So Git is a repository where we can store information. That's part of the single source of truth, part of being able to be declarative, doing validation and things like that. And then we have a continuous deployment solution, such as an Argo Flux CD. And this is how we create that declarative operational framework. And then there's an orchestrator or workflow engine that we bring in that can manage the steps of the automation on how that we want it. So in Telco, we always want to do things a special way, right? We use workflows and orchestrations to template do A, B first, right? So install this, then install this, right? So we're still doing declarative, but we can at least define what steps the declarative actions are going to take. There's also infrastructure automation, right? So I think a lot of people think a lot about the software automation, like configure, upgrade. Infrastructure automation is critical to be able to upgrade BIOS and firmware. That's going to reduce hardware failure. Lifecycle management. Infrastructure needs to be upgraded for lifecycle. It needs to be upgraded for security. So we're going to need to bring in infrastructure automation solutions. There's a lot of them on the market we work with, such as Red Hat ACM. With AWS, we'll go to Telco Network Builder. Dell's got their bare metal orchestrator. So the idea is we bring this infra automation into the equation, hook it up into the workflow, and we've got applications and infrastructure being automated together, right, end to end. And then we also need inventory systems. So these become important where we can have multiple inputs, planning tools, operations. Even the AIML framework itself can feed new direction into that inventory system. And then this helps us maintain that single source of truth. What are we building in the network? How do we want to be built? And then that inventory system feeds down into the automation framework. And then the last piece of the puzzle is the network functions themselves. So when we develop software as vendors, the software has to be compatible with that automation framework. So we have to build our software in container images. And then we need tools when I create the automation artifacts or blueprints. So Helm charts, values.yaml files, JSON configuration. So these are the kind of the blueprints that we're sticking into the automation framework and say, go build that, right? That's the instruction set. And it actually builds up the software. So that is the automation aspect of it. Now, if we turn to say, what is an AI/ML framework, right? First, we have to understand what machine learning is. Machine learning is about, you'll hear the term inferencing, right? Inferencing is reaching a conclusion, right, based on your reasoning and evidence. So what machine learning models do is they do inferencing based on an algorithm. That's the reasoning aspect, and the evidence is the data aspect. So it really starts with the data. I mean, if in our machine learning development, we'll find about 85% of the lifting in getting a machine learning model up is on the data side. So the data side is about collecting the data. We have to do things like data imputation, filling in the blanks. We have to normalize and scale. We do dimensionality reduction, which is reducing the amount of what they call machine learning features or attributes which feed the model. So there's a lot of work on the data side, and then we feed the machine learning model, and then it makes an inference. One of the inferences could be a control action, right? Change a parameter, steer traffic. So if you think about the brain, it's going to intersect with the cloud in terms of how we collect that data, because that needs to be done efficiently. And then when it gets into the machine learning part, we start processing that data, we make a smart decision, and then we feed back to the automation framework for the control loop action. So if we want to change a configuration or scale or do whatever the machine learning tells us, it then intersects with automation. So the way I kind of look at it is the automation framework is like if we're building a robot, the automation framework is the arms and legs that are going to do everything. And the AI/ML is the brain, which tell the arms and legs what to do.
Absolutely. So there are different steps. So let's go a little bit backwards for a second, then we'll move forward. So first of all, so we started having automation without the need of much AI or ML, just a little bit on the side.
Mhm.
What is that? Or is there anything that out of the sudden makes it automation more compelling? Why did we do it 20 years ago?
Well, I think people have always wanted automation, right? And I'll even like when we first went back, when we first started the cloud journey, probably, boy, it was like, I remember like in 2011 was like the first generation, like, oh, let's do software-based platforms and separate software and hardware. Then we did virtualization and we were going to be able to share infrastructure with virtual machines. And then when we went to NFV, right, and it's probably we started deploying networks around 2016, right, on NFV. The promise was bringing in more life cycle management and automation. And, when I talk to a lot of operators, they're like, we never really realized the promise of automation back in, I'll call the OpenStack days, where it was going to be an NFVO orchestrator, VNFM. We talked to the Vim and the cloud layer, and we could get this automation. And if you say why was that, and I said, look, the tooling wasn't there in the ecosystem, right? We still had to do too much development as an operator ecosystem. We had this Etsy Mano framework, and someone had to develop an orchestrator, someone had to develop a VNFM, and then we had to run plugfests and stitch all these things together. Now, if I turn to Kubernetes environment now, there's a bunch of tools, right, on the shelf that just work. We're not in Telco, we didn't code Kubernetes. I mean, that came from Google. That's a third generation Google's orchestration system. We didn't make Argo or Flux CD. It's just there. We didn't invent Git. It's there. Argo workflow. It's there. And then also, if I look at the ecosystem, there's so much more sophistication, even on the infrastructure automation, right? I'll give you an example. We work a lot with Red Hat and taking their advanced cluster management, their ACM, very powerful tool for automating the infrastructure automation, not available in OpenStack, and we work with them as an example. So I think just the fact that we've moved to Kubernetes, the ecosystem of tools available to us in the whole Kubernetes environment, so much more sophisticated than we had in the past. And also the ecosystem and the partners, whether it be with Red Hat or AWS or AMD or Intel, I just see so much more capability coming from the vendors that straddle telco, but also straddle outside of the telco ecosystem. And so much innovation happening out here that we're now able to bring to telco. So I don't think it's a matter of wanting to do automation. I just see the capabilities today are so much more powerful than they were even, 3-4 years ago.
Yeah, and I guess that there is also more of a sense of trust, because I remember the first time you talk about automation, people say, "Oh my God, this is just like it's a black box," or "Can we trust it?" And I guess that, and then trust is one of those things that sort of grows with time, and it's not a technology issue; it's just a question of getting used to it, and then. So, okay, so we got the automation part. So why do we need the AI and ML on top of that? Isn't that enough?
Yeah, see, I look at the value of automation as, you're removing the human elements from an operational process, right? We talked about it's a declarative operation. I know what I want the network to be, so you know exactly this data is going to end up in. But what we're going to do with automation, remove the human element, so that evolution, say it's a network rollout of software, that will happen faster. So I get my network operation done more quickly. I take the human element out, so that's more efficient in terms of OpEx, right? I'm not paying out the OpEx for those operational staff. And then the third part is I'm removing the human element, right? Humans are fallible. We'll make mistakes in executing a mop, but if we have the automation do it, we reduce that human element, which means we don't take an unintended customer impact, and we don't have to go do the rework, which is more an efficiency. So that's the automation value prop. Now, when I look at AI ML, right, I look at this as moving the operational envelope quite a bit. It means we can actually achieve results that we cannot get today, right, with simple automation. So, if you recall what I talked about AI ML at the beginning, it is about problem solving and decision making, right? And when we've applied AI ML now, even in networks we have automation, it's really about the operation people saying, I can now see things I did not see before, right? It's about saying, I now have recommendations on how to tune a parameter that I didn't have insight on what that meant before. So I can achieve a level of performance that was unavailable than without AI/ML. So they are complementary because they do work together. They both work together to create that autonomous operational envelope, as I say, but they're solving different problems. AI/ML is really about efficiency, right? AI/ML is achieving a whole new level of operational capability. I look at AI/ML as as network complexity increases. It's not just removing the human element. It's how do I actually figure things out and make decisions, right, in a more complex environment when things are just getting more and more complex with a heterogeneous service demand. And that's where AI/ML is really going to play a role in the networks.
Yes, because arguably at some point when the network is so complex, there's just not enough people that you could possibly hire. Because not only, I mean, even if costs were not an issue, you just can't have that many people. You can't have just people, 24 hours keeping track of so many parameters. It's just impossible, right? It's not even a cost issue at some point.
It's absolutely, it's not. I'll give you a perfect example, right? So our data science guys were shown a new causation factor to our operations people on a network, right? And they were kind of behind the firewall, and they were doing this in the live network. And through the demo, one of the head of operations was looking at it. He goes, "Oh, wait a minute." He goes, "What's that telling me?" And it was given it, the machine learning was given an insight because they were looking at the real data, but this is a demo like, hey, here's the capabilities. And the operations guys are like, I did not know that was happening. And all of a sudden he called like 5 of his staff onto the call. He goes, did you guys know that was happening? These guys were working on the network at that time. No one had an idea, what was going on. And they started using the AI/ML to deep cause, to get a root cause of the issue and drill down deeper. And all of a sudden the operations guys were like, but for that, I would never have known that, and it just gave them that deeper insight because the machine learning had really figured out the patterns of the network, because it was showing them stuff they didn't know. So to your point, it's not even about saving 5 people or 10 people or reducing, hours of effort. It's about getting results that the human brain misses. I mean, there's only so much a human can correlate different data points they can imagine. That's what machine learning does. It can look at everything happen in the network, crunch all the data, and just come up with insights that surpass what a human brain can do. That's the difference. We're talking about reaching an entirely different level of dealing with operational complexity with AI. And that's why we think it's critical. Automation is only going to take you so far. I look at automation as like a car, right? It's better than walking. Boy, that's efficient. AI/ML is a rocket ship. It's going to take us to places we haven't been before.
Yeah, absolutely. One thing that you just sort of reference point for me is like, short-term memory is like up to 5-8 items. MIMO parameters is like 1,000. So you understand that we're kind of like we're lost. You can't possibly do that.
Yeah. I couldn't keep track of all this stuff. My boss makes fun of me. He goes, man, you write everything down in your notebook. And I'm like, human brain, it's fallible, right? You can't remember everything. You can only crunch so much data. We have to focus the task. And that's really why we need AI, especially if we're talking about how complex the network's going to become in 5G and 6G, right? All the new services that are promised. I've made the point when we talk about slicing and things like that in the telco industry, I go, I don't know how we would actually respond to all these complex service demands, right, in real time, efficiently, if we don't have AI/ML deep in the network helping us out. I mean, you look at what's happening out in the real world outside of telco. They use AI/ML all over the place to solve complex problems, deliver personalization, things like that. All these things are applicable to telco. We just need to bring it in, right, and start using it and solving telco problems with these technologies that are adding value for all these verticals outside of the telco envelope.
Absolutely, and we're gonna get back to the sort of like the human factor part of it. I would just want to remind the people that you need to ask questions now and don't wait until the end if you want them to get them answered. But I want to get to, well, not to get back, but to ask you about Gen AI. And you have not really mentioned it, I think. And everybody just talks about Gen AI. And sometimes it's sort of taken to be the next version or the more advanced part of AI and ML. And we want to clear that. But what do you think that Gen AI is going to, well, you think Gen AI is going to help us, and if so, how?
Yeah, and this is one of those kind of hype type of questions, I think, where everybody will talk about Gen AI because people are using content creation, out in the wild, and OpenAI came with their Chat GPT, and people kind of starting getting a little maybe familiar with transformer networks and what GPT could do. But the reality is, AI and machine learning have been around for decades, right? It was like in the 90s, I think, when machine learning was beating the chess champions. And so if you kind of take a step back and you get out of the hype bubble a little bit, machine learning, right, is a subset of AI. AI is a subset of data science, and machine learning is really what we're talking about applying inside of the telco envelope. And in machine learning is all different types of models, a lot more than Gen AI. So Gen AI has a role, but there's a lot of other machine learning techniques that also have a role. So, when you kind of break down machine learning, you've got unsupervised, supervised reinforcement learning, and then you have different algorithms to solve different problems. Like a very common, algorithm in machine learning are regression algorithms, right? And what regression algorithms do is they understand that they learn the relationships between independent variables or inputs or attributes, right? And a dependent variable, right? What's going to happen given these inputs. And so if you think about, okay, I'm going to forecast the price of a house. I want to know what a house price is, right? That's the dependent variable label. And then you say, well, what influences house pricing? It could be things like square footage, number of bathrooms, school system. These are all what we call machine learning features. That would be a typical regression model, right? Nothing to do with Gen AI, but provides a lot of value. There's classification models, right? Think about finance industry. Is this a consumer high risk or low risk? That's a classification model. In telco, spam, not spam. We classify, a text or email, right? And we can put it through classification algorithm. Planning algorithms, right? They say, given a set of conditions, what should my next step be, right? Again, not Gen AI. Time series forecasting, if you're thinking about where a stock market price is going to go, or you want to understand where a KPI is going to go, you use a time series forecasting type model. Image recognition, not using it much in telco today, but again, that's another type of machine learning algorithm. And then, of course, natural language processing, content creation. And I think that's what most people kind of think about when they think about AML and they think about Gen AI. But the point, and when I talk about all those different tools in the toolkit, I always look at it to our data scientists. They work with the operations guys, and we say, what's the best tool to solve the problem, right? Because if you look at these large language models that are in the market, they've been trained, tons and tons of data, a lot of horsepower. Sometimes it's like killing a mosquito with a bazooka. It's overkill, right? So we pick the right algorithm for the right problem statement, and we do it in a very practical manner in telco, because you just can't throw heavy resources at everything. But if I turn to Gen AI, we do use Gen AI, right? Right now we're using it for two very specific purposes. One, data's not clean, right? When it comes into the machine learning framework, and that's just normal data science. There's always going to be missing data in your data, and there's different techniques to do it. You either say, hey, I throw that row of data away, discard it, or you figure out maybe the average, you plug the average in. But what we're doing is we're using Gen AI to impute the missing value. So by understanding, the behavior of the network, we say, what should that value be? So if we have a couple missing values, we use Gen AI to generate that data. And then another thing we're using Gen AI for is a digital twin type of concept. So we'll feed something like 125 machine learning features in, right? Attributes of the network. And then we just pump through months and months of data. And then the machine learning algorithm, we use generative adversarial networks. That's a type of Gen AI. It learns those deep network patterns, and then it's able to mimic the network. So once it's able to mimic the network, we can change any one of those variables, and it'll produce or predict what that impact would be. Now, what do we use this for? Offline validation. So if we have a reinforcement learning model, which will scare the death out of operations folks, forget about automation, right? Bringing AI ML, that really scares the operations folks. But before we let that machine learning model make a change on that network, it can run it through this deep fake digital twin and say, what is the anticipated behavior of the network? And then it can kind of do an offline validation before it applies that in production. So we use Gen AI, right, to create this digital twin for offline validation, which lowers the risk of running a reinforced autonomous closed loop operation in the network. So long story short, Gen AI has its place, but so do plenty of other machine learning algorithms to solve different problems in the telco space.
Now, what that tells me, which I think is very interesting, is that clearly Gen AI has its own role, but you use it in a very specific way.
Very specific.
Now, the advantage of that is that it might help address some of the worries that people have about Gen AI, which is hallucination, security, reliability, because when we play with ChatGPT, it's using everything that is out there. Right. So clearly what you get out of it is, of limited value, or at least you have to be extremely careful. And so the issue is that if you use it in telecoms and you have that kind of reliability, you're not going anywhere. So is this a way to address those issues? Again, security, hallucinations, reliability.
Yeah, so let me address that. So let's look at, I mentioned different machine learning models for different problems, right? So I'll kind of explain some examples there to give you a flavor of what problem, what model, and then I'll come back to what we actually do use large language models for. I think, when people think about Gen AI, they think about ChatGPT, they think about large language models. So, where are large language models applicable in telco? And then what are the techniques that we apply to large language models to make them relevant and provide value for telco? So the first part, you even mentioned security, right? So in security today, we don't use a large language model for security. We'll use extreme gradient boosting, which is a type of regression decision tree for classification. Because one of the points about security, it's a classification problem. Is that fraud? Is that not fraud? So once we do anomaly detection, we use the machine learning algorithm to run through classification. It says there's a better probability that this is fraud than this is not fraud, right? And there's different performance mechanisms we use, like precision and recall, right? Recall is, did I get all the spam? Precision is, how accurately did I identify it? And then we apply those performance techniques to be able to train the models. So for security, again, classic classification algorithm used there. For causation, right, we use something called random forest. Now, random forest is another decision tree. Unlike a neural network, you can look into what the algorithm is doing, so it gives you better insight. For forecasting the KPIs, I mentioned time series forecasting algorithms. A good one is recurrent neural networks with long short-term memory. So we use that to forecast out things. And for reinforcement learning, right, we use deep Q learning with recurrent neural networks. So the deep Q learning is a reward-based system. So what the agent does is tries to achieve a discounted reward based on action. So what influences what it will or won't do is, did it get slapped, right? Or did it get the carrot? So it's a carrot stick approach with that reinforced learning training. These are all different than large language models, right? Now, what we do use large language models, right? So I kind of talked about a lot of different machine learning techniques that solve a lot of different telco problems, right? And then what we do use large language models, they're great for unstructured data, right? So what large language models typically are, that, we know the ChatGPTs is like, what kind of data has been pumped into them? How many parameters do they have, right? The billions of parameters, and those are all the knobs they turn in the neural networks as it's trained. But those large language models are only good as the data you feed it, right? And so, people like, well, I try to get better results in prompt engineering, like I can be better about the inputs I get it, and that's going to tweak it to do. But say you have the outdated data, or the data is not there, I think you started to talk about is the hallucination problem, right? These large language models can spit out a result, and they're very confident about their answer. Completely wrong, right? And so they can either be completely wrong, the answer could be outdated, and there's no source to cite sometimes, right? So a technique that you'll use with large language models, especially for specialized things, is called retrieval augmented generation. So you start with kind of an LLM as a basic model, and then, or RAG for short, in this retrieval augmented generation, that becomes kind of a database that the LLM can tap to get updated information, relevant information, and it can actually cite the source. So we actually use LLMs with RAG, right, to deal with unstructured data. And where that's really, where we found real value in that is, we're working on something we call Copilot, which it can actually mine our operational database. Like you can look at different core file signatures, you can mine different JIRA tickets, because, one of the things that operational folks will do is if they see something over here, did it ever happen anywhere else in the network? Is there anything that's relevant to help me figure out what's happening here? And you have this mountain of operational data. And if you can mine and extract the intelligence from that to say, I've seen that something happen here, here, and here. We fixed it here, here, and here. That looks like the same thing that's happening over here. That's what we'll use large language models for, is to mine all that intelligence out of that unstructured data. And that RAG component allows us to specialize, right, that large language model to deal with our specific data set, which most enterprises have to do, right? Financial institutions, that financial data is not going to be out in the wild training the models. Medical data for HIPAA, telco data. So that's where that RAG technique really comes in. So we're using that as well. But again, everything has its place. And that's what I emphasize when we're out talking about machine learning. It's not this magic bullet, right? It's not this one model, this one technique that solves world hunger. It's about applying data science to a problem and figuring out the solution.
Absolutely. And at the same time, from the other end, it's just whatever you see with the tools that are publicly available is not a reflection of what you can do with all of those tools.
Absolutely.
If you pick the right one. So, I think that we need to be very careful. Now, we have a question from the audience on APIs from Aaron, and I'm going to read it to you. So I'm not sure what my understanding of autonomous networks is correct or not, but that it requires API calls to be able to build an integrated network automation solution. This might be a challenge in dealing with legacy network nodes existing in the current networks, which might not support APIs at all. So what could be a good autonomous network strategy for a brownfield operator? Might it need a huge investment to upgrade existing infrastructure?
Yeah, that's a good question. I think a lot of times that open API concept comes in, right? APIs are I look at it in two ways. APIs from a network function perspective are usually just exposed network services to do something that's squarely in the telco domain. So think of Kamara APIs, right? That ecosystem. That is absolutely not what we're talking about here, right? What I'll call the autonomous network envelope, right? It really has a few different components. One is the cloud component, right? So the cloud component is going to be, when you build the cloud, it'll be the hardware, what they call the CAS layer. So that'll be the OS, the container, the storage, right? So that's kind of your normal, think about your resource layer with the Kubernetes orchestration. There'll be a PaaS layer. That's where we'll do things like observability, load balancing, security framework on the cloud. And then there's an SDN layer. That composes the cloud. Now that cloud layer is going to interact, or it's going to provide a telemetry framework, right? Which then feeds your service assurance framework or observability. So think about your normal service assurance, things like your graphing KPIs, getting your alarms events, right? Standard service assurance. And that's going to feed your AML framework. I talked about the importance of data in machine learning. So that the cloud infrastructure is the feed to the data. So you can think about service assurance, you can think about network intelligence working with the cloud layer. And then on the other side, the control side, you building an automation framework that's going to be using technologies that I mentioned before: Git, CD, Argo workflow, infrastructure automation solutions out in the network, inventory systems, right? None of that has to do with APIs other than, right, the Kubernetes APIs, which are exposed from the Kubernetes layer. And typically you think of an operator or controller or custom resource definition in Kubernetes world to say, what can I plug into that Kubernetes orchestration engine? So the only APIs we really, expose in that autonomous networking are really at the Kubernetes layer, and what operators do we plug into them. And then any other operational interfaces that will take out of what I call that autonomous operational envelope and expose upward, like maybe there's OSS or BS systems in there. So but those are the different components. And a lot of times that's better done. A lot of times I show a diagram, and that's just probably a little too much for this webinar, Monica, but if anybody wants to kind of reach out to me afterwards, I can step them through, what are the components and how the different pieces fit together. And sometimes that's better done with a presentation where I can show all the different components and how they plug together.
Yeah, absolutely. Now, this actually get us to talk a little bit about the openness issue and the relationship between openness and automation. And I think that you kind of like hinted at the issue in terms of there's so many components that we need to put together. So, how do we deal with all of them? And so if you have a vertically integrated network, it's relatively easier. It might still be complex, but then the automation is kind of, you automate something that you control. Now, when you have a network that is open, or the more open the network is, the more elements you have, and those elements are independent because not only they are from different vendors, they do their own thing, and they need to be integrated. And so you can argue that clearly you need automation more rather than less, but also it becomes more complex. So how should we think about the relationship between openness, that is clearly happiness, and automation, that it's also happening at the same time?
Yeah, and there's really 2 degrees to openness, right? One is we think about open interfaces. So if you think of Open RAM, people like, oh, I can have a CU working with a different DU, can work with a different RU. Now, the value of that, right, is really about supply chain diversity, right? I can get more people building radios, I can get more people having DU, and then there's some innovation that happens there. What we're talking about here is a little different, what I call in kind of that platform stack or that operational stack, if you will. The openness is really about all the new innovation we have coming in from the partners in the ecosystem. So if I think about, conversations we'll have with AMD, Intel, Dell, AWS, Google, right? In Red Hat, all of our partners, right, are bringing in new concepts on how we operate the network. And even when people talk about, having some more integration challenges with openness, it's not really about automation to solve those open challenges, or that open challenges. I mean, there's like a one-time integration effort, but the value of the autonomous network is once everything's put together and you have that whole autonomous network put together, it's the value it's going to keep creating and dealing with that network complexity. It's the value of being able to deliver more complex services because you got a network that can handle it. So the autonomous network is really about managing the network complexity, and the integration is just really a one-time problem up front. And I also make the point too, there's always a point of integration, even if you have a quote unquote closed network, black box network, right? Which, like, I'll even take outside to RAN. I run the IMS stuff, right? A lot of times we deliver an IMS network. There's always a place of demarcation where you're going to be integrating this network into a charging system, an OSS system, a BS system, an interconnect partner, an LI system. So, networking, it always has an element of integration. It just depends where are you integrating. And when we talk about the operations level, even with closed networks today, observability, service assurance, AI/ML, none of that is black boxed into a vertically integrated stack today. All those elements, even on legacy networks, have to be added. So take any network, whether it's a brownfield or say legacy closed network or an open network, the application of AI/ML is going to be a new integration into that network operating environment. Nature of the beast.
Yeah. No, absolutely. And I think that that's, I say this is really, we're getting into a new way to think about the network and then how to,
Yes,
and the complexity,
yes.
it's easy to say, well, complexity is a bad thing because it makes things more complex, right? But it's also a big advantage because the more complexity, the more flexibility, the more choice you have. So as long
Absolutely.
as you can use it to your advantage is a good thing. I mean, you don't want to have more than you need to, but you know. Now, let me ask you then this. How do you see your role? You mentioned a lot of many partners you're working with. What do you see your role as Mavenir in sort of managing or, well, working with all of that? What is special about what you do?
Well, I'm gonna answer that in a couple ways. One, you say, what's the role of Mavenir, and then what's special. So I'm gonna answer the role
Okay.
because I have this conversation, whether it be a partner, like I said, a Red Hat, a Google, a Dell, right? We have these discussions, and I recognize that they have a very good expertise in what they do, right? No one's gonna know servers better than Dell, for example. When we get into the cloud stacks and really the deep interworking and managing upstreams of Kubernetes environment, building a security framework, right? Red Hat, very good at that. So, and then if we put that together with the hardware, but what they don't always appreciate are kind of the nuances of telco. Just like I can't appreciate sometimes the deeper nuances of what they do, they're not going to appreciate the deeper nuances of telco. So if you're going to solve a top problem from telco, guess what you have to understand? The telco problem in depth. So I always say what the role of Mavenir is so, we bring our telco domain expertise in. We really understand the problem. We understand how it needs to be solved, and we understand all those constraints around solving that problem. So we're educating our partners, right, on what that telco problem is. They're educating us on what capabilities are out there. Then it's a meeting of the minds to say, how do I apply that technology that's working for other enterprises out telco and apply it to the telco problem? And I always say, anything, whether it's AI, cloud, or automation, always has to be telcoized, which means we'll have to take a technology and then we have to configure it, set it up, use the right components, set the proper security policy to make it work for telco. And so that becomes a blending of minds and skill sets to get the solution done. So that's kind of how we're solving the problems with our partner and the role of Mavenir. Now, if we have the question about what I believe makes Mavenir special, right? And this starts from our top down, right? Our management CEO top down it's our DNA of openness, right? Since the founding of the company, it was like, oh, we're going to build software platforms and we're going to work on COTS hardware, right? So we're not going to do everything ourselves. We're going to build a part of it and integrate with other parts of the ecosystem. So Mavenir was founded on that principle. We've had an open DNA and a disruptive DNA since then. So we're very, very willing, excuse me, to work with our partners. In fact, if I just look at my past week, I met with, Microsoft on their Janus program on Thursday. I had a joint presentation with my Red Hat, colleagues in a room talking about cloud strategy to an operator, right? Monday, I was discussing, cloud strategy with VMware/Broadcom yesterday, and tomorrow I'm going to go visit Google, and I want to see what we can do in moving the needle on AI for telco. So that openness to work with partners, collaborate, talk about how we solve telco problems and innovation. Mavenir has an open DNA. What makes it special? And then the other is our culture, right? And I mentioned that to get the value out of the cloud, the AI for telco, you have to bring telco people, cloud people, and data science people. And you got to get them not to talk past each other. And that's always difficult, right? I was talking to someone the other day, and I remember, we have a PhD, our cloud, one guy that's PhD in cloud, another was PhD in data science. And I remember one day I was in the room and they were just absolutely connected, right, on their thinking process. And it took a while to get there. And I remember taking a picture. I go, this is a big day. I got one of my top cloud guys and one of my top data scientists. And boy, they're just connected on brainwave. And it didn't happen day one, right? It was almost like cats and dogs when you put these guys in the room. And then you bring a telco operations guy in the room, and then they blow everything up. They go, let me tell you every reason this won't work. right? So all of a sudden, when I got the operations guy that's now talked to the cloud and data science guy, and now the operations guy's smiling. So now I know telco domain expertise, cloud, and data science are all now blended on the same wavelength. All of a sudden, magic starts to happen, and we really start innovating what we're able to do. And I think that is special about Mavenir is we've really been able to bring these different cultures together, and it's been by design. And this allows us to think about problems a different way. You look at how a telco guy is going to solve a problem, right? I always say, like, if I bring a telco go out into a parking lot full of cars, he'll look at all the cars and go, these cars don't go for telco. He'll run off to the auto parts store and start building the car himself in the parking lot. That is the way a telco guy solves a problem. If I tell a data science guy, I go, I need you to solve this problem, he'll start thinking about, what data is relevant to that problem? What data do I have to extract from that? Or intelligent have to extract for that? What's the machine learning algorithm? So it's almost a no code approach, and then cloud guys, I mean, they're all about what tools are out in the ecosystem. How do I put them together to automate, to secure? So they just think differently about how to approach a problem, and they are all valid. But when you get all the different viewpoints all working together, I think that's when we're able to get a lot of magic happening. So, we try to build that culture internally, but we also work with our partners in that same kind of ethos to, create new and innovative solutions.
And this is really a challenge that the telecoms are facing right now in getting out of, a few years ago, whenever you talk to somebody, an operator or a vendor, they say, oh, but in telecoms, we're different. So when you talk about, IT or whoever else is doing something else in a different vertical, say, oh, but we are special. And we need to kind of abandon this idea. Clearly, we are special in telecoms in our own ways. We have different requirements, but we need to be open to what other people do so that, as I said before, we don't reinvent the wheel. We don't have to learn to do everything. We need to be able to understand what's relevant and take it in rather than doing it again. And that requires a little bit, I would say, humility. Or in a good sense, you need to accept that you can't do everything, and that's perfect, and that's the best way because that's more efficient. You don't have to do it all over again, and so that's really something that is quite important, and that goes to the point of technology versus culture. So we have a lot of technology we can use today, but in a way, the bottleneck is not the technology, but in having the appropriate culture and people working together to make sure we actually use that that technology. And I think that, as you said, importantly, it's not as a vendor that is a major challenge, but it's also for an operator. Maybe you can tell us a little bit about how you see it, because this is what you see at Mavenir. What do you see in the operators? Are they also better able, or what are the challenges they face in making sure that they have the right workforce and organizational structure to accommodate for automation?
Yeah, and that's an excellent point. And it really is a cultural change, right? And even in the operators, I've met folks that are working on cloud and the operators, but I'm like, but how much headway are you making it to get this into, I'll call it the mainstream of the telco? So you can have, a cloud strategy, or you could think about what I want to do with cloud. But the reality is there's the application or engineering owners, the operators, where they have objectives to meet. I got to get services out to network. I've got to meet certain KPIs thresholds, right? I've got a P&L to deliver, right? And so, if the cloud guys are kind of working in a little bit of a silo, right? And then they try to come back into this, there's already kind of business inertia here. And a lot of times I see it bouncing off. That's the difficult part. And we've even dealt with it internally, right? And you mentioned, telco is special. Telco is heavily regulated. Telco requires heavy performance. Telco requires security. These are the realities of telco. And even when we try to bring all these new technologies in, we have to do it, but we have to do it in a way where we're respectful of the paradigms that are telco, that the things that we need to still do in telco. I mean, if you have a service outage in telco, you're getting a call from the government. If you get a hack, right, it's all over the news. right? And you'll see a lot of what we do when we go into operations. These guys are very risk averse. There's a certain way of doing things. They're very skeptical about new things because, job one is not to break things, not to screw up. So even if we can bring things in that help, say like a telco operations, get to a new level, they've got to understand it, they've got to trust it, they've got to see it working in action, and that's a lot of the work. And I think the challenge with, and I've experienced this personally, and that's why I believe in this melding of these skill sets. I'm like, if I don't push these people together, right? If I don't get the minds working, if I don't get groups thinking the same way, then they kind of develop these solutions in silos, and then they never come together. And I think that's just natural, kind of human inertia, if you will. People are used to doing things a certain way. They know the objectives they have to have, and when we bring things new, right, you can't just throw away everything that they've been doing. You have to somehow make it work within the direction they're going, and that is always the challenge, right? How do we bring all this new capability and technology and make it work, right? Not completely disrupt what's going on today, because there's a business to run, there's operational metrics to meet, and when I bring a lot of my cloud and data science guys, I'm like, they are your end customer, understand their problems, apply the technology in a way where we are adding value and not breaking things, if you will. So that type of cultural change thinking needs to be throughout the industry for the technology to be adopted. Whether it's our operations folks or telco operational personnel.
Yeah, absolutely. And that's really a crucial thing. Now, we have only a few minutes, so I need to ask you the monetization question. And I know that you think about it in a slightly different way. You talk about value creation, which I think is a much healthier way to think about it. But so how can we justify the fact that you're going to have to put some effort into getting automated?
Well, exactly. And the value creation. So we talk about value, and you're right. A lot of people talk about monetization, one aspect of creating value. But even if we talk about, where we can apply AIML and or automation, right? AIML is very good in fraud and security. So think about the value you create there. If I can reduce spam and nuisance, right? Better customer experience. If I am able to protect the protection of the subscribers, value there. Prevent a denial of service attack. Reduce revenue leakage from fraud. All value can be created by AIML. Also on the operational front, right? If I can get better insight on how the network's behaving, we're going to increase operational productivity. If we're able to improve coverage, capacity, mobility, we're going to improve end user experience. And then there's also the efficiency aspect, right? You can use AIML to do energy savings, really smart automation to take action on the network to reduce an energy bill. And we know energy's prices are skyrocketing. So anything we can do in energy reduction adds value, right? Takes away from, adds value to the bottom line. And then, doing things like increasing spectral efficiency as an example. So even before we get to the monetization aspect, right? There's a lot of value that can be created just from, I say working smarter, not harder, right? By using, automation and AIML.
Yeah, so absolutely. So there is a lot of basically you increase the efficiency. There is a lot of value right there.
Value.
Yes, and which is more than just extracting some money from subscribers. Now, clearly, this is like a moment where there is a lot of things, a lot of changes going on. How do you see Mavenir developing new products, a new approach, new strategy over the next few years?
Well, I look at this as, an AI everywhere approach, right? And, just applying these technologies to solving problems, right? So you can talk about, we talked about applying AI in security. We talked about it in operations. And this is really operations to what we do today, right? Causation, forecasting, recommendation. I also think of AI taming a lot of the complexity coming up. So I like to think of Google Maps as an example, right? if you look at Google Maps and it says it learns from all this historical data, it understands current traffic conditions, it understands what mode of transportation you put in it, speed you're expected to go, the lights, and it can pretty accurately predict whatever route you give it, you're going to be there. And then it does this a million times over for everybody simultaneously. So if you really think about it, that's managing a tremendous amount of complexity and then offering a very valuable service to you as an individual, and everybody's an individual. And take that way of thinking, you say, why couldn't we do that with telco networks? Why couldn't we have this AIML where we understand our network so well that we're able to personalize services, right, in real time, and tailor these services for everybody? Because that's what AIML does. It's a very good service personalization type of engine. Think about Netflix, think about Spotify. And this is what AIML is really good at. And you would think about, why don't we take advantage of more of that and put it into our telco way of thinking and how we deliver services to our end customers in the market.
Yes, absolutely. And there is plenty of work to do there. I mean,
Plenty
not
of
me
work
for
to
the
do.
industry. So there is a huge opportunity. Well, Brandon, so much. Thank you so much for sharing your thoughts with us today.
Absolutely. Thank you for having me. And hey, thanks for everybody to joining. And feel free to reach out to me on LinkedIn if you have any questions. So always happy to talk about this subject. I think it's very exciting, and appreciate the time today, Monica. Thank you.
Thank you so much. And again, it was a pleasure. And the recording will be available in a few days at sensafili.com, and there will be more Sparring Partners on this topic. And so keep an eye on it, and we look forward to have you with us again next time. Thank you so much. Bye-bye.
Thank you.